Okay, good morning, everybody. So, welcome to my class again today. And maybe I apologize that my last lecture was not recorded correctly. Okay, so I will check and then I will go by quickly our last lecture. Our last lecture was slide welcome to first year experience, and lecture there was 0. Goal of this lecture was to give you some information about our first year experience program and our policies and guidelines, and an introduction about our course and about myself. So I think is everybody has some initial information about our system and about our course and policies and guidelines, right? But by the time, if there is something important, I will review and we will review that again and again if needed. Okay, but okay, so now let us give you again some reminder about the due date to withdraw this without any academic or official penalty is October 9th. I believe nobody will drop from my course. And as I know, maybe some of you were disheartened because I told you some strict and hard rules and regulations in our first lecture. Maybe I was not supposed, you did not expect to hear that, but I give you some warning and some reminder, because I like everybody to be succeeded in this course. And this is your beginning, I believe, or first course in computer programming. And by the end of this, we have only this semester is 3.5 months, right? We'll be able to teach only 3 months, about 3 months, 90 days. We have a week break. Yeah, please come forward. And I believe within this time, everybody will be able to start working on the field of computer programming and problem solving. In order to be succeeded in this course and future study life and career path, you must run as fast as possible. But I told you that I will not teach you how to run. I will only help you to walk. And it is your responsibility, and you need to learn how to walk, how to run, to learn how to run as fast as possible. The only way that I know of succeeded in this course is just study and practice, nothing else. So in our first class, I give you some rules and restrictions that are officially, but beyond that, I have my own policy that I did not tell you, maybe I did not mention in our first class, but I want to mention in this class that I want to implement from next lecture, that to focus completely on my, okay. So unless I mention, I will be recording all of the lectures video on YouTube, and I will be posting all of my programs, demo programs, on my GitHub account. So you do not need to write line by line class lecture note. I like you to just give the key points. Okay. So my restriction is that unless you use your computer or any electronic to keep your lecture note, you are not allowed to open your computer or device while you are sitting back. If you want to use your computer or any electronic device to record your lecture note, you have to sit in the front. Okay? Not for today, from next lecture. My goal is not to restrict you. My goal is to restrict you from other activities. Like for instance, we have seen that some people, they do social networking, like texting. Okay, I don't like that because there will be a lot of things we have to cover. If you lose your attention some point or few minutes, you may not understand something that will be important to learn next, something next thing. Okay, that means you do not need to really, you will see that you do not need to use your computer. Okay, but if you really need that, please come forward so that I can see your screen. What you are doing. If I see that you have opened a game or a Facebook page or something unrelated to this course, what we should do? I will not allow you to stay in this classroom. Okay. Yes, because my goal is that if you find something else important than my lecture, please do that from outside this classroom, right? Because if you open your Facebook page or something, you play a game, maybe I will be interested in to join in or someone else, right? So anyone has any objection about that restriction? If you have any objection or restriction or opinion, please contact me one-to-one or email me. Okay. Can you see it? Somewhere I can sit. You see that you will see that sometime I will sit, you hear what we are somewhere, so that I can see what you are doing on your screen, and I can see actually what you see on the actual screen. Hold on 1 second, please. Okay, so according to our lecture, then today we will start module 1. You see that we have about 10 modules, 8 modules at least. Then we will review. So a lot of things. Mostly we want to focus program, foundation of programming, and introduction to object-oriented programming. If you have any previous experience of programming, like procedure-oriented programming and object-oriented programming, that's good. But in order to be succeeded in this course, we will start from the beginning with an assumption that you know nothing. But only you have like few intention in mind. One, I discussed that motivation and attention, right? So our module 1, we will discuss algorithm versus programming in our first lecture today. and it will be good for you if you have some time and like at least 5 or 10 minutes. Download before you come into the class. Download the slide, lecture slides, and have a look at what we will be discussing in our lecture. That will be good thing for you. Okay. So anyone here know something about algorithm? What is an algorithm? Yes.
The steps you want to do. It's like pseudocode.
Okay.
It's math.
Math function code. Who else? Yes.
I might get this wrong, but I remember I think algorithms in math, not exactly, it's not like an equation where you're solving for an answer. It's more like you're taking steps to
Something close. Yes. An algorithm is, yes. What is an algorithm? Yes. Something right. Yes.
It's like a recipe how to accomplish a particular task.
Yes. More likely that is a recipe. How to complete a task, how to solve a problem, right? So we are here in this course to learn how to solve problems, how to solve a problem that is maybe a life problem or an imaginary problem or a future problem using a computer. So algorithm is a recipe or that will tell you the process how to solve that problem, right? Okay, so what do we need? So first of all, we say the motivation to learn algorithmic thinking. In order to solve a problem, we need to think algorithmically. What is that called? Thinking algorithmically. That means thinking, we have to think systematically with some step and like process are valid and sequential. So everybody, we know that if we are given an equation, okay, to solve a simple mathematical equation like 2 plus 3 times 6, 2 plus 3 times 6, so what will be the result? 2 plus 3 times 6. So if we get that 2 plus 3 times 6, so we know that we have to multiply first, right? 3 times 6, 15 plus 2, 17. But if I would tell you it is 2 plus 5, 7 times 6, 35, that would be wrong result, right? That means I did not think logically. There was a mistake in my logic, right? So in order to solve a problem correctly, we need to think logically and we need to follow traditional rules, for our arithmetic rules and calculation statistical rules, whatever we know from our early childhood. Whatever we know from our early childhood, our mathematical and statistical background, there are well enough to learn algorithm. We just need to know how to organize and implement those systematically, that so that a computer program or computer language or a computer system can understand. So let us give an example, some properties of algorithms. So like we want to give some examples of algorithm, and we will discuss components of an algorithm. Then for us to understand what is programming and how to implement algorithm using a programming language. Okay. Okay, so as we get familiar with, so an algorithm is a set of logical steps that are used to accomplish a given problem or a specific task. So an algorithm contains a set of directions or instructions. What are the instructions? For instance, if I say 2 plus 5 times 3, then instructions plus and multiplication signs, equal, addition, arithmetic signs, those are kind of instructions or direction what we need to follow. Yes. Yes, definitely we have to follow all of the arithmetic operations that we know of. There will be only a few things maybe you are not familiar with. Only maybe 10% thing. All arithmetic operation you know of. I think we will be that using that. So an algorithm contains two things. One is data and another is some instruction. As what is your name, please? Nicholas, he mentioned that an algorithm is a recipe, right? A recipe has some, if you want to cook some food or something, right? You need to have some ingredient, some instruction how to use and when to use those, right? So you have to follow the exact, mostly the instructions step by step. Otherwise, your recipe or your cooked item will not be tasty, right, or eatable. So two things, we need to implement an algorithm. That means the contents of to measure data and instruction. Okay, so if I say data, if I say 2 plus 5 times 3, right? We discussed 2 plus 5 times 3. We said 2 plus 5 times 3. So what are our data here? Our data here are 2, 5, and 3. These numeric numbers. Right? Okay, what are our instructions here? The addition sign and the multiplication sign. These are our instructions, right? Okay, so an algorithm contains at least some data we do have here and some instructions we do have plus and multiplication sign, and after executing this operation we will get a result. That is our output, right? Our output will be 17, right? That is our output. Again, for instance, based on our problem, our data for an algorithm may be of different kind. If you want to solve an arithmetic problem, your data will be most likely numeric data. If you solve a problem, for instance, cooking something, your data will be some kind of recipe ingredients like flour, soda, sugar, water, or vinegar, etc. Right? So based on our data, there will be some instructions. Okay, you have to follow. As we know that, for instance, here there are some instructions to cook something, maybe to make a chocolate. You should follow these instructions step by step. And think about the situation if you do not follow or miss some instruction or sometimes one instruction, your output will not be expected, right? For instance, if you do not heat your oven to start cooking, okay, then nothing will be cooked, right? Even if you do not start your oven while cooking something, and then we will not get anything. We will not get something, right? So we know that. So these are the very simple thing as we are familiar with. So I will go through this. Algorithm can be implemented in several ways. Okay, one of these is called, I will go through that later. Okay, let me see. Okay. So here we know that the main ingredient component of an algorithm are data and instructions. And sometimes you will see that our instructions will be more complex and complicated and complicated and complicated. And you will not get data right hand beforehand at a time. Sometime you will get have some condition. If you fulfill that condition, you will get one kind of data. If we do not fulfill that condition, you will get a different kind of data. So in order to solve a problem, it is not required that your data will come first. Okay, will tell how, when to use data. So there will be some conditional or expression. Learn those. Actually, these are the main foundation of programming, and control statements. We will give more focus on those when we reach over there. Okay, our goal in this class, today's lecture, to learn how to start programming. Okay. And let me give me a few minutes. We will come here. But before I go there, I want to tell you a story. So, everybody here, we are familiar with our apartments and house or, okay. For instance, if I have a little baby, okay, like elementary school going baby, okay, son or daughter, and if I tell my son or daughter, okay, we need to build a house like this, nice house, okay, this is my money, use that money to buy something you like to make this house. Then it's probably that what he will buy, he will go to a store, he has money, right? For instance, virtual money on Amazon or somewhere. What he will select to buy? Most likely he will select nice curtain, nice window, nice door, right? His favorite color and favorite furniture like this. Okay, something like this, right? Okay. On the other hand, if I ask a constructor or builder, okay, That if I tell a builder that I want you to build a house like this, okay, and this is my money, take my money and buy whatever you need to build this house. What is likely that he will buy? Start with. He will buy some concrete, some wood, lumber thing, or some, what else? Construction materials, right? Right? That even my school-going son or daughter, he would not think about that, right? So you see that same thing for same problem, two different kind of people are going to solve that same problem to completely two different way, right? Which procedure is more appropriate? Yes, the constructor is more, right, because he knows that he has to buy painting or lines, windows, but at the end, after he constructs the building, right? But my son or daughter, he does not have idea, may not have idea, more likely that you would need the tiles or uh, or windows or blinds all the way in. Okay, so our goal, someone, my son or little baby who has no experience about how to build a house or building, okay, he will think superficially, right? It's more likely that he will be thinking superficially, right? But an appropriate person or an engineer or a builder or a constructor who has appropriate knowledge how to build a house, okay, he will think appropriately and from, we say, bottom to up, right? But my son or daughter, he would think top to bottom, different approach. So for most of the cases, in our course, we will learn to up, how to construct like a building in an appropriate way a constructor or a developer thinks. Not likely that we get impressed when you see a complete house or building, right? It's likely that I told you that story because when you see a problem in hand, and ultimately you will be yes, but it is not a good idea when you see a problem, start writing the program. A good idea. Good idea, appropriate way, you have to think constructively and you have to proceed step by step. Understand? This is our goal. Not to think superficially, but to think critically, okay, and logically, okay, how to solve a problem. That kind of thinking is called, it has another name, is called abstract thinking, or it's called abstraction sometimes. Abstraction is a vague or is a very little something. An abstraction, you will, in programming language, in object-oriented programming, and in this field, you will hear this word abstraction a lot. But an abstraction is a concept. This is not something you can see or you can catch. We can catch, we can catch, or we can see something that is visible, right? But an abstraction is a concept. Okay? We cannot catch it. Sometimes we cannot see it. For instance, when I told you 2 plus 3 times 5, right? Sign plus and multiplication were abstract. If you are familiar with plus sign and multiplication sign, then you know what to do, right? Right? So if I would tell you 2 plus 3 times Mukhtar Hussain, my name, would you be able to solve that problem? No, right? Because the multiplication sign does not work for a string data. It needs to be another, both sides, it needs to have numerical data, right? Okay. So we will repeat this word abstraction, and in the field of programming, especially object-oriented programming, the abstraction word is used a lot. Sometimes we use abstract word in our daily life, and sometimes we avoid abstract word. Sometimes when you say the speed of a light is what? Sometimes 3 times 10 to the power 10 to the power something, right? Use that abstract word, right? 3 times some 3.3 10 to the power something, right? But for instance, if I bought this MacBook for $1,000, if someone asks me how much was this, I would not tell him that it cost 10 to the power 3, right? In this case, I avoid the abstract word, right? Although I know 10 to the power 3 equal to 1,000, I would say it's $1,000, right? I would not say it's 10 to the power 3. Okay, so again, I'm telling an abstraction word you will hear and you will use a lot in our programming concept, but this is a concept. So abstraction is vague and is unclear. The question is that why do we emphasize on something that is not clear? The answer is in order to give emphasis on something else that is more important. For instance, in our last class, I gave you an example how to drive to Kansas campus. If I do a Google search, Google Map will give me some direction how to drive to Kansas campus or downtown from here, right? It will tell me go straight 2 miles, then turn right or turn left. But it would not tell me that stop there, yield somewhere, right? Okay, because those stop or yield are abstract for this purpose. Okay, so that you give more focus on something that is more important, that driving, giving focus on front. Okay, but if Google would write the step after going 5 minutes, stop. If you follow the steps, that you might stop a long time, right? If you see the steps in a Google direction, go 5 miles, then stop, then turn right. Then many of us may do a mistake, right? I may stop there. The map Google asked me to stop. So stop is here sometimes abstract. So in order to solve a problem, sometimes we avoid abstract thing and we do something that is more important. As I give you an example, this is another example. If I ask you to turn off or on a light, okay, so if I ask someone to go there and turn off the light, okay, I know that if is good, then he will go there and he will turn off the light and he will come back, right? So there are some steps in between this. I'm not going to tell all of the steps, right? So there are some abstract or hidden steps in between. So the concept of programming or implementing an algorithm is sometimes we will avoid some abstract thing in order to give focus on something else. Okay, so I want to discuss about write a good algorithm. Okay, in order to understand that, okay, I want to focus on this slide first. So we want to understand, already know what are the ingredient or elements of an algorithm, right? Data and instructions, right? And there are some properties of an algorithm. What are the properties of a good algorithm? It must be precise. That means it will do whatever is asked to do. Nothing else. Nothing less, nothing more. Okay? And it should not be ambiguous. It should be straightforward and clear as much as possible. It must be complete and it must be correct and as simple as possible. And it contains level of abstraction. I believe all of the steps are familiar with you and clear with you unless the last one. It contains level of abstraction. So before I come here, I already gave you some idea about abstraction, right? Abstraction is a concept again. Okay, so I will come back again later, but now let us go back. What is not this game? It's not showing my screen. Share content. Okay. Okay. So let me give you another example to understand what is not a good algorithm. That means what is wrong with this algorithm. Can anyone go through this? So for instance, we want to do or here. Yes. Yes. There's two things.
It just tells you.
Yes. Three things.
Okay.
Yeah. Maybe define what ladder is. Well, yes, that means it has at least something missing, some instruction missing, right? Or incomplete. Yes.
Does it tell how many times?
Yes, that is the repeat. It is telling me rinse repeat. Okay. How many times we usually shampoo? Okay. It is easier for me. I have bolded. So, but for you, usually twice or maximum three times, right? Not unlimited, again and again and again and again, right? This algorithm is incomplete, right? It is telling me repeat and repeat and repeat. Okay, so then now you should understand that. So here, which step is missing here?
Complete.
Okay. Completeness, right? That algorithm is not complete, right? Since it was not complete, it was not correct. Right? Can anyone think that what was level of abstraction here? What are the thing abstract thing here? Yes, there are many abstract things here, right? It does not tell you how much shampoo you need to take. It does not tell you how to open a cap of a shampoo bottle, right? It does not tell you how to rinse. There are a lot of abstract things here, right? Okay, think about that. If you do not use those abstract steps here, then what would happen? Your algorithm will be large enough, right? Yeah, you can write 2 pages, 3 pages, 4 pages algorithm for doing this thing, right? Unless rather than writing a lot of steps, here what is our goal? To use some predefined our knowledge, our previous knowledge, right? I know that a baby knows how to wash hands and right. Okay, so these are the concept that an algorithm, when we will be solving our problem, we will write our algorithm precisely. Okay. So an algorithm can be described in several ways. One of the ways is called plain language or pseudocode. Okay. There can be flowchart or picture. Another can be a specific programming language. Okay, the pseudocode is the most steps of problem solving. That means so we are familiar with an algorithm, right? An algorithm can be implemented in multiple ways. In our next class we will focus on pseudocode, okay, and then sometimes pictures and then flowchart and program. Thank you so much. Please do not forget to complete your syllabus quiz by this weekend. Thank you, everybody. Have a good day. Yes, one second.